In this video, we're going to look at the different atomic theories that have evolved through the contribution of these key scientists involved in the development of these theories. Number one, we have John Dalton's atomic theory. In the early 1800s, John Dalton made 4 observations about atoms that have become known as Dalton's atomic theory. Here are the 4 statements of his theory. All matter is made up of small particles called atoms. Atoms cannot be created, destroyed, or divided into smaller particles. All atoms of the same element are identical in mass and size. The atoms of one element are different in mass and size from the atoms of all other elements. Compounds are created when atoms of different elements link together in definite proportions. What did other scientists find? Let's take a look. Oh, what is this? The raisin bun model. That's interesting. Theory number 2 by Joseph John Thomson. In the late 1800s, Thomson proposed a new model of an atom. He described the atom as a lump of positively charged material with negative electrons inserted throughout it, shown in red. This model of the atom is also known as the raisin bun model, with the raisins representing electrons. These negative particles became known as electrons. With electrons were the first subatomic particles to be discovered and studied. Theory number 3, Ernest Rutherford. Ernest Rutherford's results from his experiments using alpha particles and gold foil showed a small region of positive charge in the atoms that formed a small, dense center, and that the electrons were separate. He named this center the nucleus of the atom. He also proposed that the negatively charged electrons revolved around the nucleus. Rutherford's model is sometimes referred to as the planetary model because the motion of the electrons around the nucleus resembles the motion of planets around the sun. Isn't that interesting? Theory number 4, Niels Bohr. Niels Bohr worked with Rutherford to answer the question of where the electrons were positioned. His experiments provided evidence that unique bands of light are given off by all the elements. He proposed that electrons could only move within fixed regions or energy levels rather than being able to move anywhere around the nucleus. For an electron to move from one energy level to a higher level, the electron must absorb a specific amount of energy, which he called a quantum. This model of the atom with a central positive nucleus and electrons in energy levels around the nucleus is often called the Bohr-Rutherford model. Atomic theories number 5, James Chadwick. A British physicist named James Chadwick, who had once worked for Rutherford, was the first person to show experimentally that neutral particles called neutrons help to make up the nuclei of most atoms. So we want to take a look now at how to draw a graphical representation of an atom. The Bohr-Rutherford model of drawing electrons is still used today to illustrate the structure of an atom. Electrons occupy specific energy levels, which are sometimes called shells. Electrons in levels that are farther from the nucleus have more energy than electrons in levels that are closer to the nucleus. The number of electrons that can occupy each energy level changes as you move outward from the nucleus. Now, we're going to complete the activity to see how to draw a Bohr-Rutherford diagram to represent atoms.